In the last two videos on the subject of the transistor, we only considered the NPN and of course the thyristor. And in this one we're going to look at the difference between an NPN and a PNP. Now, both are bipolar junction transistors, but the operation is slightly different. And to demonstrate it, I've rigged up a breadboard with 2N3906, which is a PNP here, and a 2N3904, which is an NPN here. These are complementary transistors, so they can be used together in things like amplifier circuits, but here I'm going to use them in switching capabilities, and we'll just see what the difference is. Now, if we zoom in a little, not quite that much, we can see that they've been wired up quite similarly. We have an LED loading on, and the LED is linked in both cases to the voltage rail there, and in both cases the LED has a forward resistor coming out, and in both cases the bottom of the transistor has been linked to the voltage rail. And if you look here on the NPN side, it's been linked to negative voltage, and if you look here on the PNP side, it's also been linked to negative voltage. The difference comes in the way we link to bases. Now, as we know from what we've seen of the NPN, you load the collector and you make the collector face the positive voltage, and you make the emitter face the negative voltage. With the PNP it's the other way around. You make the emitter face the positive voltage, and you make the collector face the negative voltage. And what happens is the PNP will conduct the closer it gets to 0 volts. When it gets to 0 volts it's saturated, and the further away from 0 volts it gets, the less it will conduct. So then, this wire here is attached to this switch here, which is attached to the voltage rail. And when I press this button, what will happen is that the base of the PNP will receive a pulse. And as you can see, the LED goes out. PNP can no longer conduct. If I let it go, and this is quite different to the NPN, which works in the reverse way, because on the NPN I have the switch attached to a positive voltage and sending through this resistor here the positive voltage to the base of the transistor. And when I do this on the NPN, the LED lights. This of course leads to a rather interesting thing, because if I take this wire out of here and I put it here, just bear with me a moment, and I put it here, what I can do, just by pressing one switch, it causes them to oscillate. So in short then, the PNP conducts into saturation the closer it gets to ground. The NPN conducts into saturation the further away it gets from ground. And that's the difference in the two types of BJT. Well, so far in this video then we've had a look at the difference between NPN and PNP transistors, but we haven't done anything really practical. So what we're going to do is we're going to have a look at something a bit more esoteric and something in practical device, and it's this practical device, which is something I made quite a long time ago. It's a device for testing whether there is any output from a remote control. And if I take a remote control and I put the device next to the remote control like that, and I press a button, if I watch the LED, if it flickers, that means it's receiving something. Okay, and we can say that that remote control is working as it's causing the LED to flicker. And that's just a bog standard red 5mm LED, but what actually makes this thing work is this here, and I don't know if you're going to be able to see it very well, to be honest with you, but it's that little glass bauble thing there, and what that is poking out of the case is a phototransistor. And a phototransistor works by having the base terminal exposed. As the base terminal is exposed, light can get into the PN junctions, and as you know, light does contain energy, and not to get too quantum physics about it, it knocks the electrons off, and that's what causes the transistor to conduct. The more light in there, the more conduction you get. So it is rather like an NPN. So it only has two terminals, and as you can see, it has a very clear glass structure, and this is because all NPN transistors, to one degree or another, will conduct in the presence of light, and that's why they're usually covered in a big black surround or inside a tin can, so that they don't get any light exposed to them and create any extra noise that you don't want. This one in particular has been set up so that it reacts more to infrared than it does any other kind of light, and that's in the way it's doped, and it's also in the way you put the resistors in the inside. There's no real circuit to this, and basically all it is point-to-point soldering of a battery, a switch, a transistor and an LED. Very, very simple, very, very effective tool for testing whether or not you've got a working remote, all thanks to a transistor.